Okay, so the first thing that I'm going to need to do to make myself an interface is I'm going to want some actors, and I'm going to put a few things in here. The first thing is I'm going to put some markers, and they just represent the markers in the game. So the reason I want this marker is I want to be able to refer to anything on the board, and then I will subclass it from here. So I've got an X marker. Whoops. And the image is going to look like this. I'm also going to have an O marker. There's no code in these. They're just pieces on the interface. I'm also going to have a claimed one. It's nice if you look at the board and you know what's available. You don't want to have to remember. So this is an X claimed and an O claimed. Okay, so this is the interface, except for one thing. I would also like the ability to tell you what the scores are. So I'm really quickly going to code a label class with you. Something that you can improve upon, I hope, but something at least that you'd be able to use in your game and be able to now display a scoreboard to both players. Okay, so a label won't have an image because I will build it with the string. Okay. So the first thing I'm going to have here, there is no act method. It just displays it. It doesn't respond to anything in Greenfoot. But I want to know what is it that I am going to display for you. And I'm also going to make it, you can customize the colors and other things on your own, but I would like to know what size you want me to draw this label. So again, this is like the most basic example I could give. I hope that you can do better than me at this. So to build a label, give me its text and give me its size. And what I'll do is I will say, first, build me the parent class. Remember, that's always the first thing you should be doing with inheritance, extending the actor. The text is the one you gave me. The size is the one you gave me. And now I would like to draw this. And I'm going to use this as a method because we will redraw it often. So I'll make it a private helper method. Update image. And what it'll do is it'll create a Greenfoot image. And one of the things that you can build an image with are the parameters we're building right now. So you can give me your text, you can give me your size, and then you need a color for the foreground and background. So I'm going to import the color class. And in here, I'm going to use foreground color of black. So the text is black. And a background color behind the text will be white. You're welcome to customize and add different features. But there's a method in Greenfoot. Every actor can change its image on the fly. So if I set the image to the one I just created, now it will have updated things. So that's what I'll do right here. Update the image to the one that was just built. And of course, I should provide some access, so I'll set the text. And that's going to mean that what you will do for me is update what the text is supposed to be, and then I need to make sure that it's redrawn. So this is one example again why you don't want to just give direct access to the string, because changing the string has more of an effect than just the actual data. It will update what appears on the screen. And we'll do something very similar here with the size. All right, so size is equal to size. And then it should update the image once you change it. And that's all I'm going to do here. That's all I want for a label, something that can display text. Hopefully I do a little better at compiling this time. All right. And now let's build how these things are going to function together with all the rules we've already built. So I'm going to create a Tic Tac Toe, and I'll call this the view. You could call it the board or something else. Oops, I put a space there. And I've created a tile here. Let me show it to you. The tile is just that square, and it's a 50 by 50 image. I've also made sure then that my characters are 50 by 50 images as well. They'll fit on top of a tile. What it allows me to do in Greenfoot very easily then is to tell Greenfoot, this is what the board displays. And instead of talking about it like you have been previously as pixels, you can actually go in here and say, I don't want 600 by 400 single pixels. Instead, maybe we're going to do this as a 5 by 5 board. And each one is 50 by 50 pixels. So watch what happens when I build it now. There's no functioning game yet. But it's now a 5 by 5 board with all those tiles. And if I ask it things like, what's your position? Sorry, let me compile this whole thing. It's just the convenience of, again, connecting it to why we would use a 2D array. If I put one down here and I ask it, where are you? Its X is horizontal and it corresponds to a column, column number 1. So I'm not dealing with pixels, I'm dealing with positions in the array and in the columns. Again, much more convenient for us. So let's build this interface now. The first thing I want to be able to do is I have to keep track of the rules. So I'm going to have a Tic Tac Toe logic, and I'm going to call it the board. Actually, apparently I called it logic in my notes. And again, it should be private. I don't want anyone to do it except through mouse clicking, which is why I've done that. I'm also going to have 2 labels. One that shows player 1's score, one that shows player 2's score. Okay, so when I build it, here's what's going to happen. I'm now going to create that logic will be a new tic-tac-toe. And I know I'm going to use a 5 by 5 board. So now it'll keep track of the rules for me. I'm going to be a little sneaky here. And again, I built this in by using invalid as one of the possible states. And I'm going to put 2 extra rows into this game. And the reason I want 2 extra rows is I'll use one to display player 1 and the next to display player 2. So to make the rows appear, right now, if I do it, it's a 5 by 5 board with 2 extra rows. And it doesn't really, it doesn't really look like a board you'd want to play on because there's going to be all these extra tiles. So what I'm going to do is draw over top of these bottom rows to get rid of them. Okay. So this is the next thing that I'm going to be up to. The Greenfoot image that I want is the background, and you can call on it to say, get the background from my game. This is the image that's being displayed. Now I'm going to walk through the process of what I did. So I went background dot set color, and I just want to blank it out. So I'm going to use color dot white. And again, if I'm calling on that, Java needs to know where they live. And to translate this into pixels, you can get a cell size back from the world. If you're using single pixels, your cell size was just 1 pixel. But the background now is going to be filled. So the thing I'm looking for, you can look it up in the documentation, the Greenfoot image documentation. Fill a rectangle. I want to go down to the row, which is at X position 0, so all the way to the left side. And I want it to be the bottom 2. So get the height of the world. Take 2 away, so now I'm above the bottom by 2 rows, and multiply it by how big those would be. Similarly, I'm going to want to do this for the width. It's just I'm going to go on the entire width of the screen. So I'll times that by the cell size. And because I have 2 rows, this is how big I'm going to end up drawing the 2 rows. Okay, so full width of the screen is how big the rectangle is, and it is 2 rows times their cell size high. So I'll let you have a peek and, oh, sorry, I have to reset that image now. So set the background to be this image that I just altered. And now let's have a peek at what happens in the game, just so you know what I did. So now I've got a spot where I can put the players' scores. So let's tag them in here too. I'm going to create those. Player 1 is going to be a new label, and I believe I picked 24 for the font. So I'll call it Player X, and they are going to have nothing. Game just started. And let's add this object. So I'm going to put it in the middle of the screen, get width over 2, and the height I'm going to use is the row 2 up. The first blank row. So player 1, and I'll just do a quick copy paste for player 2. And player 2 is going to be identical, except it is an O. And it should happen 1 above the bottom. So just again, so you can visualize what just happened. Now I've got a scoreboard and text on there. Okay, let's pop back in, and I'll tell you how to act as a Tic Tac Toe board. This is what happens to change the state. So what I'm going to say is nothing happened unless you mouse clicked. So if green foot dot mouse clicked on this item, so if you click the board, then we can play the game. Otherwise, ignore it. So what do? I'll give you again the top-down version. You take a turn, you update what's drawn on the board, and then show the scores, because they might have changed. So those are the last 3 methods I need to plug this thing together. So what does take turn look like? All the hard work was done by the logic class. To take a turn, all I'm going to say is let's get the mouse info so we find out who was clicked. And this time the row corresponds to the mouse index and getting its Y position. The column, the horizontal, is the mouse X position. So now I just want to know, hey, Tic Tac Toe board, can I place a marker here? If that's possible, then do it. So this will update the board. Underneath the hood, all the states. The rest of these methods are going to look through that board and see what needs to now be redrawn. So I'll go here and I'll show you updating the board simply means going through, looping the board over, and updating what states were there. So public void update the board is that nested loop that you're going to be pros at by the time you're done this unit. I'm going to call it X and Y. It'll make sense in a second, but here's how far I need to go. So let's ask the board how many rows you've got, which I think I'm going to need to go and provide some access to you. And public int get columns. This way I don't have to hard code the numbers I started with into the game. And the y position on the board, remember these correspond to rows. So for y equals 0, while y is less than the number of rows in the game, increment y. X represents the horizontal, and those correspond with the columns. So what I'm going to do is find out whatever's there, get rid of it. So I'm going to say remove the objects that are on the board right now. So get them for me. Who is at that X and Y position? And I want markers. I don't want to remove everything from the game. Any markers that were previously there, please remove them for me because I'm about to update the board. The state I'm at right now is to say, ask the board to get me the state at the row and column. So remember, row is Y, column is X. And now I'll say, if the state is, I have an X marker, and this comes from the Tic Tac Toe logic. Then that's what I want to put on the board. So add an object, a new X marker at this position X and Y. So it's going to be pretty similar for the rest of them. I'll find out, could you be an O marker now? And if you are, add an O marker. The other states that we could encounter are things like, have you been claimed? So let's say, what if you were an X claimed? Then I would like you to place my new chip here. And then the final state that you could be is an O that's been claimed. That's that red O. And there are no other valid states on the board. The errors and the empty, you don't need to put anything, but the errors, of course, we wouldn't draw. So at this point, we're done. We don't have to check any other states. And this will blast through that board and make sure that the states we see in the 2D array are now represented on the board by actors. Show scores. All I'm going to do now is set the text of the different players so that we can talk about what they are. So score number 1 is ask the logic to get a score for the, let me see here, Tic Tac Toe logic X marker. Maybe I'll call it score X then, just to be. And I'll do the same thing for the O marker. So here I will say player 1, which was the text for the first player's label. Set the text to be X and score X. And then I will do the same thing to player 2. So for player O, we'll do that there. Okay, so now I actually have a working game. The only thing I haven't incorporated in here is I haven't actually taken that method I told you about earlier, which was stop the game if you can play. So that's what I'm going to do up here, is I'm going to say if logic.canPlay. That's okay. What I'm concerned about is, what if you can't play now? There's no need to go on in this game if that says it's false. So what I'm going to do is, what happens when the game is over? And greenfoot.stop. So I'll have my last method here. All I want to do is display the winner. So for a game over method here, I'm just going to go and get the scores again. So I'll go and get these two. Because I want to know who won. So I'll say if, let's go, string result is X wins. If score X is actually smaller, then I have to change the result. The other thing that could happen is score X equals score O, and the result is it's a tie. So now I'll put this message on the screen. So I need another label. Winner is a new label. And all I'm going to display is the result in font 24. And I'm just going to stick it right in the middle of the screen. So add object winner to get width, divide by 2, get height, divide by 2. Okay, now I don't know if I'm going to compile without any errors here, but this point is a working game. We should be able to test. Hopefully I can, yeah. Let's see here. Get objects. Oh, it's get objects at. See how lucky I'm feeling. Not so at the moment. Get score, which means I've copy and pasted that error a bunch of times, unfortunately. And let's see. Player 2. All right. So I know you're dying to see the game played. Maybe not. But when I click here, nothing happens. First player is an X, right? And then I can do things like, you know, run a few. And let's see, I'll put the O here. At this point, when I place an X, well, I didn't place an X. I guess I'll put it here. I've got 3 that just I wanted to show you the multi-line connection, but I just got 3 claimed squares. Now they can't be used again. If I was to put my chip here as the X, it doesn't register because that doesn't count. It's already been claimed. So anyways, I will let you play with the code on your own terms, and hopefully this is a starting point for us.